Okay, this is problem 1 of homework 2. What you're seeing on the screen now is the data that I entered, concentration versus time. I've also created 3 graphs of that data. The first graph is on linear scale. The other one is where the y-axis is made log, so this is our semi-log graph, and then the third one is log scale on both x and y, so this is our log. I've created 3 graphs, and if you don't know how to create these graphs, you should go back to the other video or ask me. But I created these 3 graphs on the same page so we can look at them, although it would be perfectly fine for you to just update the axis and try to figure out which one was linear. But when you see them all together, it's clear that the semi-log appears linear. That tells me that the function that will fit that data is exponential. And it also tells me that when I do the data analysis, time will be my x values and log of the concentration will be my y values that I'm going to use in these various sums. So the next screen you're going to see is I'm going to get rid of these two graphs that don't apply, and I'm going to expand my table, and then I'll start filling that in. Okay, here is the essentially what I had before, which is my concentration versus time data, and then my one graph where the data appears linear, which is semi-log. And I've added a few columns here so that I can do my sums. So again, since it's semi-log, the x, or the time, is my x values. The log of the concentration will be my y's, and then I'm going to have to square my x's and multiply my x by my y. So the first thing I want to do is then complete the rest of this table. So again, y is going to be the natural log of the concentration. Let's undo that. So if I have a mistake, undo can be my friend. So let's do that again. Equals ln of the concentration. I want my xx to be B7, which is the time, squared, so caret 2. And the xy column is my concentration times the log of B, my y values, my log of my concentrations. Alright, so I have my 3 columns filled out. Now I'm going to select those, grab and copy all 3 at once, so that makes life a little easier. And let me quickly format this by first removing the borders and then adding borders. Okay, so now I have my 3 columns. Now I need my sums. So remember, the sum is nothing more than summing all the data and then dividing by the number of data points, which is an average. So let me do that. Spell out average. And parentheses, grab my average data and hit enter. So now you can see I have my average going from B7 to from B7 all the way to B16. And then I want to copy that, so let me grab this again, this corner, and I'm going to copy over. That's going to update the columns. Ooh, let me undo that, didn't grab it properly. There we go. And I don't need to sum my concentrations, I need to sum my logs, so I'm just going to delete that one. So here we see now my averages of the D column, the E column, and the F column. So now I have my 3 sums. Now that I have my sums, I'm going to calculate my A and B values. In this case, I'm going to take a little bit of a shortcut in that I know what my A is. I actually don't have to calculate that. My A is just my initial concentration, so I'm going to add 6. in that spot right away. There's no need to calculate it. And if you notice, the second set of equations is if I know what my intercept or my value at t equals 0 is. Therefore, my intercept when I'm doing my semi-log analysis is going to be the log of a. So I'm working this a little bit backwards than maybe you did. All right, so the intercept is actually 1.79 and so on. And therefore, when I calculate my slope from a known intercept, I use that equation. So let me type that in. If you look at your notes, that'll be equals parentheses F18 minus the known intercept D21 times B18 close parentheses divided by E18. Now if you use the other formula without knowing the intercept, you'll get a slightly different value, but it should be close to 0.40. And the units on there is 1 over minutes. Now that I have my A and B values, I'm going to go ahead and calculate my concentrations based on that. So that's going to be in my F of t column, right? These are my calculated concentrations. And the equation I'm going to write in there is equals A times EXP of B times my first time value. And I'm done there. And I can see that my initial value is indeed 6. However, when I copy this, all of these column numbers are going to get updated, and the only one I want updated is my time. So I'm going to put a $ in front of the 22 and a $ in front of the 20. Now when I copy this, the only thing that gets updated should be the number after the B. So, whoops. I'm having a hard time grabbing things today. And let me format that quickly. All right, so now I see that as I move down, you'll notice that the number after the B changed, but the other two didn't. That's what the $ does. And the other thing I'll notice is that these numbers are close to my data that I measured, right? They're not exactly the same because these are calculated value, these are measured, but they should be close. This is an indication that you've hopefully done something correctly. And actually, let me get rid of that for a second because it automatically entered it in there. Now if I want to add that line, I'm going to highlight my data, right click, select data, and I'm going to add a data series. Where my X values are my time and my Y values are my calculated concentrations. And now you'll notice, and then hit OK. And you'll notice I have two symbols on top of each other because they're very close, but it's really, I want to edit that because the second thing I'm plotting is actually a function. So I don't want marker styles. So I don't want any marker fill. Or actually I want no markers in my options. For the line color, I want it to be solid. And when I close that, I'll notice that I get a line, which is the calculated concentration versus time, and I still have my symbols, which is my measured concentration versus time. And that's all it is.